Hello, everyone. Welcome to the KNIME GenAI Learnathon, Enrich Data Analytics with GenAI. We are about to start, so I would like to also thank the people that joined online. And I guess we can get started, right? Okay, so welcome, everybody, also for the people on site. In this Learnathon, in this Learnathon, the goal is to, we're going to have a big use case, which is the detection of frauds, leverage GenAI. And the part where we're going to leverage GenAI is for the creation custom alert messages for our clients. So we're going to have a first part, and we're going to see today how to do that, where we process the data, we process the data, and also we learn about how we can implement techniques for fraud detection. And then in the second part, we finally let AI basically jump in. We're going to see how we can prompt basically a large language model within KNIME, first with a simple, let's say, prompt style, and then we're going to also introduce a more complex system, a retrieval augmented generation system, and then basically we're going to see how we can produce custom emails. Okay, so, and before we continue, my name is Roberto, I'm a data scientist at KNIME, and together with me today there's also Lada.
Yeah, I'm also data scientist at KNIME, and
Lada will take it away, and I'll come back for the GenAI.
Yeah, I'll start with introduction to KNIME, and then I'll give you a brief introduction to fraud detection problem. And yeah, as Roberto said, then he will show you the most interesting part of this Learnathon about GenAI. Okay, let's start with the intro to KNIME Analytics Platform. So KNIME Analytics Platform is a low-code, free and open source tool to basically analyze your data, also build applications in data engineering or data science. You can transform your data, you can visualize your data, move your data from A to B, build machine learning models. So basically anything you need to do with your data, you can do in this tool. And what does it mean, low code? The tool is using the visual programming paradigm. This means that you build your projects in so-called workflows. Maybe I can use in the workflows. And the workflows basically consist of nodes. Node performs one particular task on the data. So you will build such workflow step by step, and each node performs some particular task on your data. And each node then has a name, so that you understand which task it can perform on your data. It might have input and output ports, or maybe only input or only output ports. This is where your node receives the data and also provides some output. And then it also has the status, and we'll talk about the statuses a bit later. KNIME software in general covers the whole data science lifecycle from creation to production. KNIME Analytics Platform that we will mostly work with today allows you to build solutions, and then KNIME Business Hub, which is the commercial part of software, allows you to put them in production. So deploy them, the solutions that you built with KNIME Analytics Platform, and allow your users to consume your solutions and to interact with them. So I say that each node performs some particular task on your data, and there are many nodes. There are more than 4,000 nodes in KNIME Analytics Platform. Each of them performs, most of them perform one particular task. There are nodes that perform multiple tasks. And of course, you don't have to learn 4,000 nodes. You just need to find the one that can help you solve your problem. Let's have a brief look at the groups of nodes that are there. So first of all, when you start working with the data, usually you need to access the data. And there is a group of nodes that can help you to access the data from different sources, from the files, from very simple tabular data files such as CSV, Excel, and so on and so forth, to more advanced files that allow you to access also unstructured data such as images and texts. And also you can access data not only from local machine, but of course from remote file systems as well. Of course, you can access data from databases, SQL and NoSQL databases, and also from different web services, and you can also send REST requests. Also, you can access big data from different sources such as Hive, Impala, and HDFS. And also you can process the data in Spark or within the database from KNIME by using but at the same time using the resources of the database. So you can control the process in KNIME Analytics Platform, but you can use the resources of the database or Spark cluster. Then there is the set of nodes that can help you transform the data. So, for example, filter rows, clean the data, merge the data, aggregate the data, and so on and so forth. You can also build machine learning models in Analytics Platform from classic ones such as regression, classification, and clustering. Of course, you can from cross-validation, evaluate your models, and optimize parameters. You can also build more advanced models, for example, with Keras, and also you can integrate AI, as we will see today. Also, you can visualize the data in Analytics Platform in interactive visualizations. There is a set of nodes that usually they are blue color. They allow you to create a visualization, and it will be provided as a separate window where you can also interact with visualization. And you can also build dashboards that consist of multiple visualizations. And finally, there is a set of nodes that allows you to export the work that you've done in KNIME, either into a different location. So if you just wanted to read your data, process it, save it again, you can do that, but you can do much more. You can build reports, you can export visualizations that you created, and also you can deploy models and so on and so forth. Okay, so how do you install KNIME Analytics Platform? KNIME Analytics Platform currently is running on your desktop as a program that you need to download. It's free, and you need to install it, and then you can directly start working with it. When you install KNIME Analytics Platform and you open it, and the next thing that you need to do is to select the workspace in which you're going to work with your workflows that you're going to build. So there is this concept of KNIME Workspace, and this is basically a folder on your local machine where you will save the workflows that you will create. Okay, so then when you installed KNIME Analytics Platform and selected the workspace that you're going to work with, you can open it and start working with KNIME Analytics Platform. So the first page that you'll see will look like this. Here you can see some examples, but most importantly, you can see your local workspace. It is called local space. And this is where you will create your workflows, where you can also import workflows from others and also export your workflows to share them with others. And here you can create a new workflow. Okay, so once you open a workflow that already exists, or if you create a new workflow, it will appear here as a separate tab. If you open more of them, they will appear there on the upper part of KNIME Analytics Platform as separate tabs. And here is your workflow. And this part of KNIME Analytics Platform is called Workflow Editor. And this is basically where you will create your workflows. We'll talk about Node Monitor a bit later. Let's now have a look at these tabs. So there are 4 of them. The first one is called the Description tab, and it basically shows you the description either of a node that you selected, so you can see the documentation of the node, you can see which tasks it performs, which input it requires, which output it provides, and also how to configure it. If you click on a workflow, you also will see the description of the whole workflow. So basically, this is your documentation. Another tab here is called Space Explorer tab, and this is basically your workspace in which you work. You can navigate to different workflows, to data files, and so on and so forth. Okay, the next step is very important. It's called Node Repository tab, and this is the tab where you will take your nodes from to use them in your workflow. You can drag and drop them directly from the node repository to your workflow. And then you need to connect nodes between each other by dragging the connection from one node to another. So as I said, each node has a status, and there are 4 of them. So once you drag and drop a new node to your workflow, you will have this first situation, red traffic light with a warning sign. This means that your node is not configured. Before you can actually apply it to your data, you need to tell it how to do that. So it has some configuration parameters, and you need to configure the node. Before you configured it, the status will look like this. Then once you, for example, here you have the Excel reader that obviously reads an Excel file into your workflow. And so at least one parameter that you need to provide to this node is, of course, the Excel file that you want to read, right? So once you configure the node, then you'll have the status that is yellow traffic light. This means it's ready to be executed. So it's ready to perform its task, but it hasn't done so yet. And then once you execute the node, it will have this green status. That means that the node executed successfully, and the task that you want to perform on your data actually successfully got executed. In case there was some error, for example, you wanted to read non-existing file or something was wrong with the format, in this case, you would get this status with the error message, basically. And if you hover over this red cross, you'll see the error. Okay. Node monitor is a very useful feature that right away shows you the output of a node that you selected in your workflow. So this is on the top is your workflow editor, and if you click on each node, right away in the node monitor that you will see on the bottom part of your KNIME Analytics platform, you'll see the output that this node provides. For example, this node, you can see it has two outputs, so two data tables, and here you will have two tabs for each of the data tables. Also, you'll see the table dimension here, the column names and types, and you can also search and filter in this table. And if you have any missing values, they will be shown as this red question marks. And here there are two modes. So one is the table, you probably cannot see, but so this one that is selected now shows you the table directly, the whole table. And another one shows you the summary of the table, so basically some statistics that describes the table. Okay, so some nodes can provide you with interactive view. And to open an interactive view, of course, first you need to configure and execute your node. And then you will have this magnifying glass button. Once you click on it, a new window will open, and there you will have your interactive visualization. And you can also interact with it, for example, by hovering over the bars. In this case, you'll see some tooltips with additional information, but there is much more interaction that can happen there. Yeah. Okay. So if you work in your local workspace, basically all your work will be saved there, but sometimes you might want to export your workflow, maybe to share it with a colleague, or other way around, import the workflow that already exists. Maybe some of your colleagues shared it with you, or maybe online. So for that, we have special file extensions. There are two of them. One is for one single workflow, and another one is for archive that will archive the whole folder of workflows. And let's see how to export the workflow. Let's have a look at this right side of the slide first. To export the workflow, you need to click on the workflow or folder that you need to export, right click and click export, and then it will ask you where you want to save it, and it will be saved in one of these formats that I showed. And other way around, if you want to import the workflow, you can click on this menu button and then click import workflow, and then select the file on your local machine from where you want to import. And for files, there is a separate option here to add files. They can be of any format. Okay. So additionally to KNIME Analytics Platform, we have something called KNIME Community Hub. This is basically a hub that is available to anyone in the web browser. So basically a website that you can access from any web browser. And this is the place where you can search for all the nodes that are there, additional extensions, example workflows. You can upload your workflows there as well. You can also version your work there. You have a private space there, the public space, if you want to share your workflows with community. And this is, for example, one place from where you could take examples and then download them and import them, as I showed on the previous slide. Okay. And then also, when you install KNIME Analytics Platform, you will have the default nodes available there. There are many of them, but we also have extensions that you can install additionally. And those extensions allow you to do a bit more specialized tasks on your data. For example, if you need to process text or images, we have additional extensions for text or image processing, respectively. We have extensions for deep learning, geospatial analytics, and many, many more. To install them, you can click on preferences, on menu, and then on install extensions, and you can just search for extension and install it, and it will then be available on your local machine as well. And final thing that I wanted to say about KNIME Analytics Platform is KNIME AI Assistant that we call KAI shortly, and it also requires its own extension. And then once you install this extension, you will have this assistant that has two modes. The first one is the chatbot, where you can ask, for example, how can I build a workflow to solve some particular task? It will provide you with an answer, but also with the nodes already that you can use, and you can drag and drop them from here directly to your workflow. And another mode that it has is directly workflow builder, so you can ask it to build a workflow for you, and you can see whether it solves the task that you wanted to solve. Okay. Then we have as next the topic of fraud detection. I think we will continue with this, and then we'll come back to the questions at the end, just for people who joined online. So I also will give just a very brief introduction to the fraud detection topic so that we have more time for AI part. Okay, so in our example today, we'll start with this first part where we just read in the data, pre-process it, and detect outliers. And then we will move to the GenAI part. We'll see how to introduce GenAI into this application of fraud detection. So let's start with the fraud detection. So I guess everyone knows what fraud is. This is some intentionally deceptive action to get some unlawful gains. And of course, it can impact individuals negatively, but on larger scale also industries, entities, and so on. So there are different types of financial frauds. Today we'll talk about contract frauds in contracts, but there are many more other fraud types such as tax fraud or credit card fraud. And of course, even if they happen rarely, we want to detect them as soon as possible to avoid these negative effects. So in our examples, we will detect the fake or wrong contracts. And we will have the contracts as PDF files saved. They will look like this. And we will try to find the outliers. So the contracts that are significantly different from other contracts, from the majority of the contracts. In the contract, we have three values that will parse from this textual data. This is the ID of the contract, the value of the contract, and the date of the contract. And we'll try to find the contracts that are significantly different from majority of contracts with respect to the value of the contract. So we'll have the data from two different sources, from PDF contracts and also from a database. And to detect fraud and then to also use all the information about these contracts in the GenAI application, we will want to combine these two tables to have as much data as possible about the contracts in one single table. Okay, so how can we actually detect fraud? Of course, you can do it manually, but if you have too many contracts, that's probably impossible, time-consuming, also prone to error. And of course, we want to do it with data automatically. And So a common way to detect outliers, to detect fraud, is via outlier detection techniques. Outlier is, as I already mentioned, a data point that is significantly different from the majority of the observations. In our case, this would be a contract that has a significantly different contract value from other contracts. On this picture, for example, we have you can see we have 6 groups of data that are kind of clustered, and we have this one that kind of doesn't belong to any of them, so this could be considered an outlier data point. Yeah, and as I said, outlier detection techniques are often used for fraud detection. What are those techniques? There are many different techniques for numeric data and for nominal data. For numeric data, you can use the visualizations. You can check the outliers from using the statistical properties of the data. You can also build clusters of the data and see which data point doesn't belong to any cluster. And you can also build machine or deep learning models. And for nominal data, you can use the string similarity metrics. So many options are there. Today, we'll just look at the simple ones because we want to just learn how KNIME Analytics Platform works and then move to the GenAI topic. So we'll just look at the visualizations and statistics. Okay, let's have a brief look at different visualizations that we can use for the outlier detection. So actually, you can build any visualization that can help you to detect outliers. There are many options. Today, we'll just have a look at some of them to compare different categories of data, to have a look at the correlation between different dimensions, and also to add the distributions of the data. So, for example, if you want to compare different categories in your data and find the outliers, in this way, you can build either a bar chart or pie chart. Bar chart may be more useful if you have more than 2 categories because it's easier to compare different categories from many of them. Pie chart might be good for 2 categories. If you have more categories, might be not that easy to see the differences anymore. You can also build visualizations for correlations, such as scatter plot or bubble chart. And scatter plot can help you to see the correlation between 2 categories, 2 dimensions. And bubble chart can help you to see the correlations between 3 dimensions. You can introduce the 3rd dimension by increasing the introducing the size of these bubbles. And here you can see then which data points don't fit into the general trend. Those can be considered outliers. You can also build histogram or violin plot to check the distributions of your data, and again see which data points you can see very rarely in your data. Those can also be considered outliers. And then finally, 2 visualizations that are probably used most often to see the outliers in the visualizations is a box plot that summarizes the 1 numeric column. So you can see basically the summary statistics about this column, such as median, first, 3rd quartile, minimum and maximum that you expect in your column, and those values that are outside, they are considered outliers. And again, the scatter plot, again, if you see the correlation and there is a data point that doesn't fit into this general trend, you can consider it an outlier. Or if you see clearly there are some groups of data and 1 data point doesn't belong to any of those groups, you can also consider it an outlier. Of course, you don't have to use just 1 visualization. Actually, you can build multiple visualizations to see better whether your assumption about outliers is true. And in KNIME Analytics Platform, you can build a dashboard with multiple visualizations by creating a component. If you don't know how to do that, we'll have a look together. You just need to build the visualization separately and then wrap them into a component and then see the visualization that combines these multiple visualizations. Okay, so pros and cons of the visualization techniques for outlier detection. So the visualizations look nice and they help you to explore your data even if you then go and use other techniques as well. This is usually a good start to understand your data better. And then if the outliers are easy to spot, you can also directly interpret them. So why are they outliers? You can see, for example, they don't fit in any of the groups if you have the groups of data. At the same time, you can only check 1 or 2 dimensions at a time, because we can build maximum 3-dimensional plots, and then you still need to check manually. So if you want to automate this process, you could use, for example, the simplest would be to use statistical properties of your data. And one possible technique here is called interquartile range technique. And I already briefly showed it on the box plot. So you first find the median of your data, then you find the first and third quartile that is median splits your data into a lower part, lower half and upper half, and then you find the first and third quartile that also split respectively your lower half and your upper half also in halves, and then you can calculate the interquartile range as third quartile minus first quartile, and you need to select a hyperparameter k that is in Analytics Platform by default equal to 1.5, and then you need to calculate 2 values. First one is this one, third quartile plus k multiplied by interquartile range, and another one is this one, first quartile minus k multiplied by interquartile range, and then all the values that lie above this data point or below this one will be considered outliers. So basically, you would have your expected minimum and maximum, and this is what you calculate here. And all the data points that lie outside, they will be considered outliers. In KNIME Analytics Platform, you can implement this with just one node that is called numeric outliers, and you can also additionally build a box plot to visualize the same thing. And then the advantage of this technique is that you can then automatically detect the outliers. It's still a very easy technique to understand. And in Analytics Platform, you just need 1 or 2 nodes to implement it. The main disadvantage is that it's just one-dimensional analysis, so you apply it only to one dimension, whereas sometimes you might have an outlier that is based on different dimensions. There is another technique that is called zeta score. We will not use it in the exercises, but the idea is quite similar. Just another disadvantage of this technique is that it assumes that your data is normally distributed, which is not always the case. If you want to do multi-dimensional analysis, there are more techniques that you can use, for example, clustering, machine learning, deep learning, but we'll not go into that today. And I will give over to Roberto to talk about GenAI.
Okay, so thank you, Lada. Right, and just since we have a few more people in the room now, just to make sure that you are in the right place, this is the KNIME GenAI Learnathon. What Lada has just explained was a little bit of an introduction to KNIME, and also she provided a few important information about how you can do fraud detection in using 2 techniques, visual techniques and statistical techniques. And now, in the other part where we're going to talk about GenAI, we're going to basically have a look at the second part of what we're going to do today in the hands-on session. We have done initially the first part where we talk about basically importing the data and also using visual statistical techniques. And now we're going to see how we can leverage GenAI in Analytics Platform to basically generate automatically custom email alerts, but also how we can enrich and customize those email alerts using retrieval augmented generation, all in a low-code fashion. Okay, before we start, and obviously this will be the output, basically an email that we can, a test that we can send to our potential customers at risk. Okay, before we go we dive deep into let's say the exercise. Let's bring everybody on the same page in terms of what LLMs are, what AI is, and so on. So LLMs stand for large language models. They are a class of deep neural networks that revolutionize really the way we interact with such technology. And they have basically they excel. They are very good at tasks that have to do with understanding and generating basically conversation, natural languages. So this is why they are extremely helpful and often used, in a conversational setting to interact. We usually have two two characteristics that define LLMs. They can be multi-purpose or multimodal, or both. We talk about multi-purpose LLMs when the LLMs can master or excel at different tasks. For example, question answering, text summarization, or text generation, text completion. This is typically or historically before the having LLMs, you will need to train deep learning architecture specifically for one task, maybe go to the next task. So it was not a multi-purpose in that sense. So we need to basically have different training processes and for your model to be good at one single task. The other aspect is the LLMs can be multimodal. That is, they can take as input or produce as output not only text, but for example, also images or audio files. So they are able to work with different types of data formats. And well, some of the most popular example, I'm sure here you already at least heard of some of them. OpenAI's ChatGPT or GPT-4, Bard by Google, Dolly's by Databricks, and so on. There are several out there. Some are open source, some are closed source, and so on. But why are called large language models? To be fair, the concept of large language model is not entirely new. In fact, it emerged already in 2018 with the concept of when the architecture, the deep learning architecture called Transformer, was initially published, or the paper was published by researchers at Google. Now, why we don't call that large language model, we call our current models large language models, because back then, even if we are talking about millions of parameters, they were nothing compared to what we have today, which are hundreds of millions or even trillions. And in fact, the large depends on the size of the trainable parameters to smaller path, but also, and with that also the proficiency that they've acquired over time. And let me show you this little picture here. You can see a little bit the evolution of, and the bubble would indicate the number of trainable parameters, the size of these models. And you see with GPT-4, for example, in the picture, which we don't know exactly the actual number of parameters, but there are only estimates, but you see how over time the evolution of size in terms of number of trainable parameters has been increased, and also the proficiency. And just to give you a little bit of comparison, OpenAI GPT-4 is estimated to have about 1.76 trillion trainable parameters, compared to GPT-3, which was, let's say, the previous top-tier model that they had, which is only 175 billion. So that's why we don't usually call anymore model like BERT, that was released in 2018, a large language model, because that only had a couple of hundred million, so nothing too big compared to what we have today. Okay, but how do LLMs think? You have to think of their sort of mental process, allow me this word, as a highly sophisticated completion mechanism, like one you have on your phone when you are maybe WhatsApp, when you're typing a message. So when you type a message, the application is already suggesting what is the next most likely word to come, so for you to be able to type faster. And they work in a way, in a very similar fashion. They were trained on millions and millions of texts, so they learn, for example, what is the most likely word to come next after a sequence. In the slide you see, the example, the sky there's our initial string of text, and the models learn, because I've seen it during training over millions of texts, the most likely word for it, for example, would be blue. And so that's exactly how the model will learn and would predict the next word. So after, for example, the sky is blue, there might be then after that another word. That obviously depends how good this, let's say, the predicted word is. Obviously depends on the text and the data the model was trained on. Okay, so obviously if the data has poor quality or was incomplete or had biases, those biases or that incompleteness will be reflected in the ability of the model to generate the token. Okay, and with LLMs, we have different ways in which we can interact and we can customize their responses. We break it down here into four, let's say, categories, going from the simplest one, which would be prompt engineering, up to the, let's say, most complex, most sophisticated, which is using conversational retrieval agents. And we have here also a blog post that we published on our blog, where we talk about this techniques into say, greater details. We're going to now have a look at each of this, let's say, of these interactions, and think of it as building on top of each other. So the simplest one is prompt engineering. This means that hyperparameter tuning builds also on top of prompt engineering to, let's say, achieve a higher degree of customization and better interaction. So what is prompt engineering? I mean, this is probably the simplest option, and I'm sure if you have used for example, ChatGPT on the browser, this is something you probably already know what it is. Basically, this is simply providing some instructions to the model, hopefully in a way that is clear and concise, so that the model will be able to generate the output that you have requested. There are some best practice for doing this. For example, basically using a very simple and concise language, avoid, for example, redundancy or providing sentences or commands in a, let's say, in a with a negation. Models tend to perform better when they receive commands in a positive. So do this instead of do not do that. Don't do this. So I mean, there are plenty of best practice out there, and in KNIME Analytics Platform, we can craft our prompt using this string manipulation node. There we have the option to bring basically string or text together, to join them, also to parameterize the strings. So for example, in a way that we can automate the process of prompting the model. We will see that during the exercise. So this will be the first and essential, let's say, the most the simplest way we can interact with another. The second, let's say, level of interaction would be by doing some hyperparameter tuning. What does it mean? We can tweak some of the settings, let's say, let's put it like this, of the model, so that it adjusts to our needs and to the task at hand. Some of the common ones, and here you see, for example, the configuration, one of the nodes that we will use later on, is, for example, to choose the temperature. What is the temperature in large language model? You need to think of a temperature as sort of a big knob that in some way regulate the randomness of the output produced by the model. So if I want to allow for a more creative, more, let's say, random output, then I can increase that temperature. If I would like to have a rather deterministic output, that is, always have the same output for a given prompt, then I should decrease that. So yeah, ideally, if I change temperature to 0, that should result in a deterministic output by the model. Another important, let's say, hyperparameter to take into account is the max tokens. The max tokens indicate how many tokens we can use, or the model can, let's say, can use to produce a specific output. And you need to take into account that max token includes both the tokens of your prompt, but also the tokens that you hope the model will use to generate the response. Okay, so if I, for example, in example, have 100 tokens here on the slide, this will have to be enough to account for my prompt, but also for the text that I would like to generate. If I would like to have a longer response, for example, or I know that my prompt is going to be longer, then I should probably increase that to maybe 200 tokens. Okay, a token, just to be clear, is roughly corresponding to a word. So one word, one token, more or less. Okay, no, it's not exactly 101, but we can allow this level of approximation. And another, say, third hyperparameter, which is sort of a hyperparameter, is a context window. The context window would be the ability of the model to, so a number, let's say, that defines how many tokens the model would be able to process in general. So if it would allow the model to look back into the text or into generate a response, this would be this could be as much as the context window. And this is something we cannot super, let's say, govern ourselves, in the sense that to do that, we would need to retrain or fine-tune the model. But what we can do is we can choose smartly a model that has smaller or larger context window. So depending on the task we would like to basically solve. So in the upper part, you see there are different model IDs. And the first one, GPT 3.5 Turbo, is the actual name of the model of ChatGPT. That's how it actually is called by OpenAI when you use the model. The other ones, you see there is the next one on the right, is having the number 16K. This indicates that in that case, the context window, so the number of tokens the model will be able to process at once is maximum 16K. Okay, so that is a way we can say, okay, we don't need such a powerful, let's say, model, such a model that has such a powerful context window. We're happy with something a little bit smaller. Also, take into account these are closed source models, so that means that usually you are charged for it, for the use, so you can be smart about which one to use according to the task. Okay, the third level of interaction has to do with retrieval augmented generation. This is a much more complex process. It involves different elements, but it also is very powerful because it allows us to customize the responses of our model. So, you know, for example, that the models that we have that are, for example, ChatGPT or similar models, at some point they had to cut the training. They had to stop, training the model so that they can finally release it and for us to use it. Now, this means that some knowledge or very recent events or very specialized knowledge wouldn't be able to make it, right? Because the training, for example, was stopped in 2021. If we ask for a fact that happened yesterday or last week or a month ago, the model will not be able to provide a correct answer. And so how can we still make sense or make use of the generative ability of these models to actually update or complement their knowledge? And that's the process of retrieval augmented generation. This process requires a user, let's say, define knowledge base, so say a set of documents or code or images, or it can be anything. So a knowledge base that is meaningful for the user. So we have to create that first in the first part. This could be, and this obviously is use case relevant, right? If I am, for example, would like to do something with images, probably I should collect maybe a big gallery of images on flowers, for example. If I would like to, for example, have a model that is more knowledgeable about legal text, then in that case, my knowledge base would be a set of documents, maybe court cases that have to do with the domain that I'm interested in. Now, this information should be embedded and loaded into a vector store. Here we have I mentioned two important words, embedded and vector store. And embedding, we will see what it is in a few slides, is basically a transformation of this knowledge, so documents or images, into a number, into a vector representation. So we want to have basically vectors with numbers. Now, those numbers, those vectors, are then stored in a vector store. A vector store is a sort of database, but unlike the usual relational databases where we store tables, here we store collections of vectors that contains obviously our documents. On the other side, so on this side where we have the user, we can finally now ask a specific question. In this case, in the example, we are asking what are the types of investor agreements. Now, this question is a very specific question to a specific context, a specific domain. So if we would ask this, the model now okay, if you ask ChatGPT about this question, probably we'll still get some output. But is it the output that we would like to have in our specific case? And if, for example, if we work for a bank and the bank has a specific type of investor agreement, not all of them, but just maybe 2 or 3 that it offers to clients, right? So we want to customize and fine-grain that response. So what do? So we prompt the model. By this time, we first embed our request, our prompt, and then we perform a sort of similarity search on the vector store, so that afterwards, the most meaningful, the most similar documents are retrieved, and with that information, the model can finally generate a response that is relevant for our specific use case. But this is just a little bit of an overview. We're now going to break it down each piece into more steps. Okay, so again, what is an embedding model? An embedding model is a model that will transform a sentence, for example, the Oscar for the best actress goes to, into a vector of numbers, a numeric representation. Okay? Now, if I have another sentence, for example, Argentina wins the Soccer World Cup, and I ask my model to embed that sentence, you see in the circle would be our vector space. You see that because the 2 sentences are different, talk about something different, their numeric representation would be, and the representation in general in the vector space would be far from each other. And that would make sense, right? Because in one case, one document is talking about the Oscar, the other one about soccer. So it makes sense that in the vector space, these 2 documents are far away. And now, if I have a vector store, which is basically a database that contains a vector representation of those documents, it could be something that looks like that. So we have sort of all some text with their embedding, so their numeric representation. And you see those documents, except for the first one, they all talk about soccer. And in the vector space, they are more or less, the ones that talk about soccer, more or less close to each other. And that would make sense, right? They all talk about soccer, why would they be located in different locations? Now, if I now ask, as a user, as a prompt model, and ask, who won the Soccer World Cup? My message, my request, my prompt is embedded. And it makes sense now that my request is embedded and is located here. So you've seen the gray dot that is close to other documents that talk about the same topic, right? And so this means that the vector store will be performing a similarity search and retrieve documents that are most similar to my request. And in this case, for example, would be Argentina win the World Soccer Cup, so the second entry. Then Bayern Munich wins the Bundesliga in 2023, and then Stuttgart says first class. So these 3 documents are those that are most similar to my prompt. Now, we have, let's say, decompose the element to RAG. Let's have, again, another iteration about how the interaction works. So we first create our user-curated knowledge base. It could be anything. We load that knowledge base. We load, transform, add embedded, and store it in the vector store. That would be our example of different text about soccer that we saw in the previous slides. In the use case that we're going to have a look at today, we're going to be acting as the bank. This is coming later. So we have this document that is sort of an internal document of a bank, so it's not available, for example, freely on the internet. And what we want to do is we want to embed it and store it in the vector store. On the other side, we have the user that now asks, what are the types of investor agreement that the bank actually offers? Again, we embed this request and we perform a similarity search on the vector store and obtain, basically we can retrieve that document and provide it to the LLM so that the response can be crafted. But that is a little bit the RAG process. And now the last level, of interaction, which is a bit more complex, and we are not going to be actually having a look at this today, but it is possible to also do it in KNIME, is the use of conversational retrieval agents. These basically enhance the LLM basically with the ability not only to chat and to generate responses, but to smartly identify where to look for the information. So it's not anymore the user that says, okay, use this vector store to look for the information or the document that is most similar to my request, but given a set of different vector stores, understand on your own which one, where to look for, and which answer makes the most sense for my request. So it's a smarter, let's say, approach to use LLMs. And this is, for example, very useful in case you would like to create a chatbot, right? Imagine many different documents, many different resources, for example, a vector store for images, a vector store for text, a vector store for code, and you then ask your LLM for something, and then the agent will be able to smartly understand where to look for and how to craft the response that is relevant to the user question. Now, how can we do GenAI in KNIME? For that, KNIME has an extension. Lada already had mentioned the concept of extensions, which are a set of nodes that expand the functionality, the core functionality of the platform. They're all for free as well. We just, as Lada already mentioned, we just initially, when you download the platform, we don't ship everything. Otherwise, you might end up having a very big program on your computer, and maybe you don't need this, or you don't need other extensions. So this is for each user to customize a little bit of the platform as they wish. So this extension has the option to use both, to connect to both to open source and closed source large language models by an API, or using open source local models. And as you see, we have the nodes on a little bit of an overview of the nodes that we have in the extension, and we have node to authenticate to a specific service. For example, to authenticate to OpenAI, or to authenticate to Hugging Face if you want to use open source model that work by API. But we also have connectors. So, for example, we can connect to ChatGPT, GPT-4, or to all the open source models available on Hugging Face. Or if we want to, for example, connect to a local open source model. And for that, we have integrated the project that is called GPT for All. It's an open source initiative that has nothing, let's say, to do with KNIME, which just integrated because they offer open source local models, so you can have the model running on your machine. And for example, this is a good use or a good example if you are maybe concerned about data privacy and sending data to the APIs. This would be an option. And then we have also nodes to create embeddings, which we saw is important to be able to have a RAG process, a retrieval augmented generation process. We have nodes to create vector stores and also to create and to work with agents. And the blue one that you see here, the little one, this one is also is basically able to connect to DALL-E in case you want to generate, for example, images. So it's not only for, so the nodes work both for text basically and for image generation, or for tasks that have to do with images or text. Here we also have a little webinar that our developers of the extension have run in October last year. So just for you to watch it at home if you're interested. And for today's exercise, the main topic is, as I said, is that of fraud detection. So detecting frauds in contracts. And the element that would be, let's say, the main outlier has to do with the amount of money that is indicated in those contracts. And the idea is that banks monitor the risk of potential fraud constantly, and ideally they should be alerting their clients that are at risk of fraud promptly, so that they can take action, right? So they can maybe say, hey, contact us because we identify the possible risk of fraud. Let's see what we can do. So the idea is that there is a bank A, identify some fraud. And before we had AI, without AI, usually what banks did is they basically were using templates, especially if they had a customer base that spoke many different languages, right? Had a template for English, one for French, and so on. So this worked in a way, but of course you can see the limitation of it right away. So it is a rather slow process. It doesn't scale very well as soon as you have a new community that speaks a different language. It doesn't allow for parameterization because you have a fixed template. Every time you change something or you like to change something, it needs to go through let's say, process of approval and so on. So it is possible. It's a bit likely though. If we use AI, on the other hand, we have the possibility to leverage the multilingual capabilities of those models to generate basically text in so many different languages. And in this way, we have a faster process, it scales better. We can introduce this into a pipeline that automates the process. We can parameterize our prompts and so on. So we have a much more flexible and scalable approach. Okay, and so as I said, in today's exercise, more specifically, we're going to read, first of all, data PDF contracts, and from basically this contract that Vlad already has shown before. And then we're also going to have, we're going to read basically clients' data. So those data contain information. Obviously, all that is fictional, right? We generate it's synthetic data, they're not really customer data. But just for the sake of the example and the exercise, we created some clients' data where we have their name, their emails, and the contract type that they have agreed with the bank. Then we're gonna have you guys do some fraud detection with the techniques that Vlada has already explained, and then we're gonna prompt our LLMs first in a simple way, so just a simple prompt with LLM, and a second step we're also gonna use vector stores and embedding models, so to have a retrieval augmented generation process, and finally the idea is that we are able to basically generate a text so email messages basically in different languages according to basically the language of the customers that is a risk of fraud. And the exercise is going to be divided into 4 different, let's say, sections. And the first one is going to be, as I said, the detection of fraud. Then we're going to have an LLM. So we're going to use an LLM for completion. And then we're going to be basically prompt engineering prompt to query the LLM and using the OpenAI nodes to generate email alerts. In D, we're going to use a knowledge base. The knowledge base in this case is going to be investor agreement definitions that the bank owns. So the internal definition the banks own for 2 specific investor agreements that are available for the customers. And then E, if we make it to that point, we're going to also deploy our workflow as a web application. So and then we can basically see and consume it on the web browser. E is also optional because to solve this part, we normally need to use KNIME Business Hub, which is basically our commercial component. So for you guys that are on site, this will be given to you today for free. So just try it out. And for who is obviously at home listening to us, well, you should join us one of our on-site events as soon as it's closer to your city. Okay, but anyway, in any case, will be able to see the dashboard that we're going to create also already in our let's say open source software. We just won't be able to see it basically as a web page in the browser. Okay. And so these are the tasks that we're going to see in details. You see for each exercise, we have basically steps. So we split the topics into steps, and we have clear instructions there for you to follow. And in A and B, we're going to access the data. We're going to basically extract information from the contract, prepare data for visualization, and then we're going to basically also perform outlier detection with statistics. In C, we're going to finally, from the model, we have the option to connect with the models, prompt it, use the string manipulation node to create our prompt, and then observe in the table view a little preview of how this message was generated. And indeed, we use the knowledge base to customize the email alerts that we're going to send to our clients. And here you see we're going to include a little bit of the vector store that I mentioned before. We're going to create a vector store. We're going to retrieve some information from the vector store. We had to use embedding models. And finally, this is a little dashboard that we create to visualize those generated emails. Yeah, and this is obviously for deployment. If we make it to the deployment part, that's how it will look like. All right. So for people that are online, the streaming session is ending here. We would like to thank you for joining this section. You find the exercises at either scanning the QR code or by going to this tiny URL /KNIME GenAI exercises, or third option, go to the KNIME Community Hub and basically type GenAI Learnathon, and there you will find the material. Is there any question? Okay, if you have any question online, just type. We're going to stay connected a few more minutes like this while the people on site maybe start getting prepared. And otherwise, that's it from our side. For the people online, thank you for joining. Type your questions, however, in the Q&A if you have any.